Hello, everyone, and a very warm welcome to today's session. I'm delighted to have you here. Today, we will be exploring the fascinating topic of software process. I am Ms. R. Anapriya, Assistant Professor from the Department of Computer Science at Sri GVG Visalakshi College for Women. This presentation aims to give you a clear understanding of the key concepts and stages involved in software development. We'll cover the fundamental processes, their importance, and how they contribute to successful software projects. So, let's get started and dive into the world of software processes. Let's start by talking about what a software process actually is. Essentially, it's a structured set of activities that we follow to develop a software system. Think of it as a roadmap that guides us through each step of the development journey. These stages typically include planning, where we define what needs to be built; development, where the actual coding happens; testing, to ensure everything works as intended; and maintenance, which involves updating and fixing the software after deployment. Understanding this process is crucial because it helps us improve the efficiency of our projects, making sure we use our time and resources wisely. It also increases predictability, so we can better estimate timelines and costs. And most importantly, it leads to higher quality products because each stage is carefully managed and monitored. In the context of this presentation, recognizing the importance of a well-defined software process sets the foundation for exploring how we can optimize and manage these processes effectively across different projects. Let's take a closer look at software process models. These models are essentially frameworks that guide us through the development of software. They help us organize our work, manage complexity, and ensure we deliver quality products efficiently. There are several common types of process models, each suited to different project needs and environments. For example, the waterfall model is a linear, sequential approach where each phase must be completed before moving on to the next. It's straightforward but can be inflexible if requirements change. On the other hand, iterative and incremental models, like the spiral or agile, emphasize repetition and refinement. These allow for more flexibility, frequent feedback, and adjustments throughout development. They're especially useful in dynamic projects where requirements evolve. By understanding these models, we can choose the right approach tailored to our project's size, complexity, and stakeholder needs. Ultimately, selecting an appropriate process model is crucial because it impacts how smoothly the project progresses and how well it meets its objectives. The waterfall model is a classic approach in project management and software development. It's a linear and sequential process, which means that each phase must be completed before moving on to the next one. Think of it like climbing a staircase. Once you finish one step, you move to the next. This structure emphasizes detailed documentation and upfront planning, so everything is mapped out clearly from the start. It's especially effective when you have well-defined requirements and don't expect many changes along the way. This approach offers a lot of clarity and simplicity, making it easier to manage and track progress. Overall, the waterfall model is about taking a structured, step-by-step approach that fits well with projects where stability and clear goals are key. Let's talk about agile methodology. This approach really centers on iterative and incremental development, which means we build and improve in small steps rather than trying to deliver everything at once. It's all about being flexible and working closely with the customer throughout the process. By doing this, teams can quickly adapt to any changing requirements and deliver working software more frequently, which keeps everyone aligned and the project moving forward smoothly. Another key point is that Agile values individuals and interactions over rigid processes. This focus helps teams stay responsive and enhances the overall quality of the product. When people communicate openly and collaborate effectively, we end up with better solutions and a more engaged team. Overall, Agile fits perfectly into our theme of adaptable, customer-focused development, making sure we're always responsive to needs and delivering value step by step. Let's take a closer look at the spiral model. This approach combines iterative development with systematic risk assessment, which makes it particularly effective for large and complex projects. The key idea here is that instead of following a linear path, the project progresses through multiple cycles, allowing for ongoing refinement. Each cycle involves four main activities: planning, risk analysis, engineering, and evaluation. This structure helps us identify potential issues early on, reducing the likelihood of failure later. By continuously assessing risks and making adjustments, the spiral model ensures that we can manage uncertainties effectively and deliver a more reliable product. Connecting this to our overall theme, it highlights how proactive risk management and iterative progress are essential for tackling complex development challenges successfully. Now, let's take a closer look at software process activities. These are the core tasks involved in developing software, and understanding them is key to managing the entire process effectively. First, we have requirements engineering, which is all about gathering and analyzing what the users need from the system. This step is crucial because it sets the foundation for everything that follows. Next is system design, where we translate those requirements into a blueprint for the software, focusing on architecture and components. After design comes implementation, the actual coding and building of the software itself. Once the software is developed, we move into testing, which is essential for catching errors and ensuring quality. Finally, there's maintenance, the ongoing process of fixing issues, making improvements, and adapting the software as user needs evolve. When we look at these activities collectively, we see how each step connects to the next, forming a continuous cycle that ultimately aims to deliver a reliable, high-quality product. This understanding helps us better manage projects and meet stakeholder expectations throughout the software development lifecycle. Let's talk about requirements analysis, which is a really critical first step in any project. This is where we gather and analyze the needs of the stakeholders, as well as the conditions of the system we're working with. It's all about understanding what everyone expects and what the system needs to do. Having clear and well-defined requirements is absolutely essential because they serve as our roadmap throughout development. If these requirements aren't solid, it's easy to go off track or end up with a final product that doesn't meet user expectations. This phase really sets the foundation for the entire project. It helps us ensure that everyone is on the same page from the start, reducing misunderstandings later on. So, in essence, requirements analysis is about laying a strong groundwork so that the development process can be smooth and aligned with what users actually need. Let's talk about the design and implementation phase. This is where we really bring the project to life. It all starts with creating the software architecture, basically, the blueprint of how everything will work together. Then, we translate those requirements into actual code. Designing involves defining the different system components and how they will interact through interfaces. Think of it as planning the building blocks of our software. Implementation, on the other hand, is the process of writing the code itself, turning those designs into a working product. A key point here is emphasizing modularity. By designing modular components, we make the system easier to maintain and update down the line. This approach also boosts scalability, allowing the software to grow as needed without becoming unwieldy. Overall, this phase is crucial because it ensures that our software isn't just functional, but also efficient and sustainable. It's the foundation that supports everything else we do, so paying attention to good design and clean coding practices really pays off in the long run. Now, let's talk about testing and maintenance, which are crucial stages in the software development process. Testing is all about making sure that the software works as intended and that it's free of defects. It's like giving the software a thorough checkup to catch any issues before it reaches the user. This helps ensure reliability and user satisfaction. On the other hand, maintenance involves updating and improving the software after it's been deployed. This could mean fixing bugs that weren't caught earlier, or adapting the software to new requirements as technology or user needs evolve. Both testing and maintenance are essential. They help us maintain the quality, efficiency, and longevity of the software over time. Together, these activities form the backbone of delivering a durable, high-quality product that continues to meet user needs long after initial deployment. They remind us that software development isn't just a one-and-done process. It's an ongoing effort to keep everything running smoothly. So, to wrap things up, effective software engineering really depends on having structured processes in place. These processes should cover important models and key activities throughout the project. Choosing the right process model is crucial because it guides how we approach each phase. And speaking of phases, diligently executing activities like requirements analysis, design, testing, and maintenance makes a big difference in the quality of the final product. When we do these well, we're more likely to achieve successful project outcomes. It's also important to remember that software development isn't a one-and-done deal. Continuous evaluation and adaptation are vital throughout the entire life cycle. Things change, new challenges arise, and staying flexible helps us deliver better solutions. So, in essence, the core message is that structured processes, careful execution, and ongoing improvement are what lead to high-quality software and successful projects. Thank you all so much for your time and attention today. I truly appreciate your engagement and interest. Remember, the key takeaways from this presentation are the importance of collaboration, innovation, and continuous learning in achieving our goals. I hope you found the insights valuable and applicable to your work. If you have any questions or want to discuss further, please don't hesitate to reach out. Once again, thank you for being a wonderful audience and for your commitment to growth and improvement. Have a great day.